Hello, Algebra 2. Welcome to Solving Radical Equations Retake Notes. Remember, you need your notebook out. You need something to write with. This is step one of the retake process here at the last couple weeks of school. In order to earn your retake, you not only have to take all of these notes and prove to your teacher that you have them down, you also need to do a practice. So make sure you are pausing the video when you need to and copying down everything. We will be checking that it's all done. If it is not all done, you will not get to retake. Okay, so this is for the second quiz of the quarter, which is solving radical equations. Now, we have three types we're going to go over. The first type of radical equation is radical equations with one root. So if we look at the problem below, we have negative 2 times the third root of 3x minus 2 plus 5 equals 9. We can see that this problem only has one root in it. It has a third root. So our goal here is step one is to isolate the radical. Meaning we have to get this radical all by itself. So what I'm going to do is I'm going to highlight the radical and everything inside of it so we can see everything we need to move. So we have the third root of 3x minus 2 highlighted. Anything not highlighted needs to be moved to the other side. So we can see we have a couple things we're going to have to move. We have this negative 2 out front. We have this plus 5. Both of these have to move before we can even think of continuing. So I'm going to draw a line down my equal sign once I switch over to my pen. So squiggly down the equal sign. Let's go. So here we have negative 2 times the third root of 3x minus 2 plus 5. Now we want to get rid of this plus 5 first before we deal with this multiplication. So in order to get rid of a plus 5, I'm going to subtract 5 on both sides. Because remember, I'm getting my root all by itself. So canceling this out, we have negative 2 times the third root of 3x minus 2 equals 9 minus 5. That is 4. Okay, let's highlight that again because I do not think it's by itself yet, but we're getting closer. So we're one term closer to isolating the radical, but we still have this negative 2 here. Now, the number one student mistake here right now is students like to try to add 2 over. But remember, if we were to read this out loud, this is negative 2 times the third root of 3x minus 2. So the opposite of negative 2 times would be negative 2 divided by. We're going to divide both sides by negative 2. Okay, divide both sides by negative 2. When I divide both sides by negative 2, my negative 2's on the left are all gone like we want, and we're left with the third root of 3x minus 2 equals 4 divided by negative 2 is negative 2. Okay, so step one is all done. It is isolated. I'm just going to put a little check mark here. We've isolated the radical, so what should we do next? Well, we need to remove the root with a power. Okay, so we need to get rid of our third root, and the only way to get rid of a root is using a power. Okay, so we need to figure out what power can I raise both sides of my equation by in order to get rid of this third root. Well, since it's a third root, it makes the most sense to take both sides to the third power. When I raise both sides to the third power, now my third root is all gone and I don't have to worry about it. So I have 3x minus 2, my third root is gone, equals negative 2 to the third power, which is negative 8. Okay, remember also whatever you do to the left, you have to do to the right. Since we raised the left side to the third power, I have to make sure I raise the right side to the third power. Okay, so step 1 done. Our root is all gone. Step 2 is done. So finally, step 3 is solve for x. The only thing we have left to do here is solve for our x, which is just a 2-step equation. I'm going to add 2 to both sides. Those are gone. I have 3x equals negative 6. Last but not least, divide both sides by 3. And x equals negative 2. And I'm all done. Solved for x, we can go ahead and check it off. So our 3 steps, we isolated the radical, we removed the root with a power, and then we solved for x. This is your first type of radical equation. It's radical equations with one root. Okay, don't forget, isolate, remove the root with a power, and solve for x. Okay, again, we have 3 types. We're on to type 2, so we are getting there. Type 2. First one was radicals with one root. Now we have 2 roots. As you can see, I have a square root of 5 minus 3x, and I have a square root of 6x minus 3x. I have 2 roots. Okay, here I like to use the saying, we need to kill 2 birds with 1 stone. We need to try to figure out a way we can get rid of both of our roots both at the same time. In order to do that, our first thing is to make sure that we have roots on opposite sides. So right now, both of our roots are on the left side. We want one on the left, one on the right. So our step 1 is to get one root on each side of the equals. We need to get one root on each side of the equals. Right now, both are on the left side. We're going to move one. So I'm going to move this square root of 6x minus 13. Since it's being subtracted, I'm just going to add this entire thing, 6x minus 13, to both sides of my equal sign. Okay, I'm going to add it to both sides. So all that's left on the left side is the square root of 5 minus 3x equals the square root of 6x minus 13. And there we go. We have one root on each side. Okay, and just like the first type, our next step is to remove the powers, or remove the roots with a power. We have square roots, so we are going to square both sides. And as you can see, when I square both sides, I'm killing 2 birds with 1 stone. Both roots are gone. The roots on the left are gone, and the root on the right is gone. So we're just left with 5 minus 3x equals 6x minus 13. Okay, roots are gone. Check that off. Last step is to solve for x. Okay, let's go ahead and move our 3x over. There's a lot of ways we can solve this. I'm going to add 3x to both sides. I have 5 equals 9x minus 13. Okay, I'm going to add 13 to both sides. So I have 18 equals 9x. Divide both sides by 9. And x equals 2. Okay? And we're done. The solution to this problem, my type 2, is x equals 2. Okay, make sure you have all of this done. That is type 2. We have one type left to go, which is type 3, which is going to require some factoring. So hold on tight. Type 3, radical equations with one root and a variable. So here it looks a lot like our first problem. We only have one root, however, we have a variable on the other side. So this is going to make things a little bit different. Our first step, just like before, the first thing we need to do is remove the root with a power. So I have a square root, which means I am going to need to square both sides. That is the only way I know how to get rid of this square root. Okay, so when I square a square root, it goes away. I'm left with 13x minus 3 equals 2x squared. Remember, this is the same as 2x times 2x, which is 4x squared. And now my root's gone. Okay, now you'll notice, though, I can't solve for x like I normally have been because I have 3 terms none of which are like terms. I have an x squared, I have an x, and I have a 3. But you'll remember, hey, this looks a lot like a quadratic. So I'm going to move every term to one side. So I'm going to get everything on one side, and I want to make sure that I have my terms in order. I want to have ax squared plus bx plus c. Okay, I want my x squared first, my x second, and my naked number last. Okay, so let's subtract my 13x over. I have negative 3 equals 4x squared minus 13x. Again, the reason I moved 13x first was because I want it to go x squared, then my x. I have x squared and then my x, and then I'm going to add 3 to both sides. So on the left side, I have 0 equals 4x squared minus 13x plus 3. And there's my order, x squared, x, 3. Okay, x squared, x constant. Okay, now in order to find my solutions, I have to factor. Yay! So I need to know my A, B, and C and use my diamond method. Okay, so our last step is to factor. I like to factor using my X method, where I do A times C on the top, B on the bottom. My A value is the number in front of x squared. My B value is the number in front of negative 13. My C value is the number at the end, 3. Okay, now it's time to draw my x and factor this. So I'm going to draw a nice big X. Up on the top is A times C, and B on the bottom. A times C is 4 times 3, which is 12. My B value goes on the bottom, which is negative 13. Okay, now's the fun part. I have to find my missing numbers. I need 2 numbers that multiply together to give me 12 and add together to get me negative 13. So I like to think of all the ways to make 12. I could get 1 times 12, 2 times 6, 3 times 4, but the only ones that work to add up to negative 13 is if I take negative 12 times negative 1. If I multiply these, negative 12 times negative 1 is positive 12. But if I add them, negative 12 plus negative 1, it's negative 13, so that works. Once I have my mystery numbers, I need to divide them by my A value, which is 4, right here, and simplify my fractions. Negative 12 divided by 4 is negative 3. Here, negative 1/4 is already simplified. To write my final answers, you just have to switch the signs. So instead of negative 3, it's going to be positive 3. Instead of negative 1/4, it'll be positive 1/4. And these are the solutions to my problem. I will zoom out so you can see the whole problem. Okay, so remove the root with a power, move everything to one side, make sure they're in the right order, factor using your diamond method, and then switch your signs after you've done your diamond method, and those are your solutions to the type 3. Now, those are all the 3 types of problems you'll need to know. This was just step 1, taking the notes. Remember, you have to have them all written down. If you have them all written down, you are now ready for step 2, which is practice. So click on that practice and start practicing. Once those steps are done, contact your teacher, Tufts or I, Mr. Tokar, and it's time for your retake. Good luck.